Hello and welcome, my dear friends. Now we are going to learn about digital logic design. Well, this is the ultimate point where the engineering mind always ponders upon because this contains the next level. What is the next level? Well, we learned that how to make the memory. Well, I introduced you with the memory by using the inductor and capacitor combination, but now it's time to understand its logical point of view and how the things actually do what they do. So let's start with the very basic part, which is there is technically two basic classification that we can have for our digital logic design subject, which is combinational circuit and sequential circuit. Well, let me introduce you that what is the combinational circuit. Well, as per the simplicity, just remember two words. Combinational circuit do not have memory, so it is having no memory. And sequential circuit is with the memory, so it is having memory, or you can also call it as storage, pretty much the same thing. So this is about the whole concept. Well, this is the fundamental thing. Now, whenever we are working with the combination circuit, we have to remember that whenever we work with no memory, it means you are switching on the fan and you are switching off the fan. So it will only work on that basis. It will not work for its own. That's the fundamental thing. Well, for the clarification purpose, let's go deeper into it. So, welcome to the combination circuit world. Well, in the combination circuit world, we are going to learn so many of the fantastic things. Let's start with its key definition so that we can see everything with our eyes building and working out. So, a combination circuit is a switching. Let me write that clearly so that we can learn. A switching circuit whose whose outputs are are determined only by the let's say concurrent inputs is called as we know, combinational circuit. So this is the fundamental definition. I hope it worked for you. Well, why I have not written it already? Because I wanted you to show the glimpse that what the combinational circuit actually means. Well, what do you mean with that, Om? Can you please explain? Yes, sure, my dear friend. A switching circuit whose outputs are determined only by the concurrent input is called combination circuit. So, if I write the definition before telling you and not writing in front of you, that will be called as sequential circuit because it's already in the memory. I already wrote that, and now what I did, I wrote this simple definition of the combination circuit in front of you, so it's live processing work. So when anything is working on the live mode, live, well, that's very much famous in our era when we see the videos, live videos, and live internet and all that such kind of the things. So this is live working thing that is known as combination circuit. So to give the experience of that, I have not written it previously and I'm writing the definition alongside. I hope you understood my point of view for that. Okay, so let's understand the definition. A switching circuit. It says that a switching circuit is there. It means it can switch according to whichever way we give the input but we can determine the output only by concurrent input. So here the concurrent means if I am providing the input on, let's say I am providing the on, so it will work no matter after 5 seconds I said off, after 5 second gap it will going to off. So it is not working on its own or on the basis of any memory. No memory is influencing it. It is keep on updating. It is keep on updating in live mode, and that the thing is called as yes, absolutely. That the thing is called as combinational circuit. So it works on live mode. It's keep on updating. Like let's say, let's imagine a simple thing so that we can understand it quite clearly. There is a table, any kind of table you can imagine, like where you are studying, maybe you are on the table. So here is a book. Now this, let's name this book 1. Now if you want this book to be removed and place another book in its place, which is book number 2, you want to write place this book on this place in place of book number 1. You want to update it with book number 2. So what you are going to do, you are going to remove this book. Let me change the color so that I can show you clearly. Okay, so we have to remove this book 1 or pick it out of the table and then put book number 2 on its place. So what we just did with this particular space that is covered by book number 1, this particular space that is covered by book number 1 is updated. It means it's working on the live mode. On the same space only one book can exist, either book number 1 or book number 2. So we put book number 2 in place of book number 1, and that is known as combination circuit. We keep on updating the things on the basis of concurrent inputs. I hope I made my point a little betterly clear. Okay, now let's proceed to another level of abstraction. So what here I would like to tell you is there are so many presentation or representations of the combination circuit. So I would like to make you introduced with the logic states that you are going to see whenever you see the notes or books or maybe articles or any place wherever you learn and advance your skill in digital electronics, you are able to see that things. So let me classify that for you so that it will be just once and forever. Okay, so it can be true or false, just like the on and off I said, and obviously it's on and off. Remember the switching system, switch can be on or off. So in the same way our books can write true and false, and what else it can write? 1 for on or true and 0 for off and false. Okay, what else it can write? High, low. Well, high and low is about the voltage, obviously. And at last, plus V of S, which is voltage of source, and 0 volt, because we are not having any voltage here. Okay, so this is the classification that everything means pretty much the same. So maybe whichever author you are following, whichever book you are following, and whichever person you are following when you are learning, and what you are going to follow going to depends upon these things. Whenever you say one of these, we will understand that what you meant with that, either on or off or start or end or something like that. So these are the states of it. Well, okay, we understood this, but you said this is another level of abstraction, and this seems not kind of the abstraction. This seems a simple idea. So where is the abstraction? Well, yes, absolutely, you are right. This is not the complete abstraction I was talking about. So the thing is that I was talking about and wish to take you is Another level. Okay, so let's go there and learn something. So as we know that we are learning the logic of the subject, so we are writing something and I'm just writing it up. Just read it out and figure it out that what does it mean. Well, this is one of the best exercise I always used to do. I just write till the time I write the definition. You have to figure it out that what it actually means. This is a brain exercise. So let's begin with this. So I am writing it down and let's begin. Combinational logic circuit. Combination logic circuit. Okay, let me write it clearly. Logic circuit is a type of logic circuit combination logic circuit is a type of logic circuit containing only logic gates. Well, I hope you remember the logic gates that we have studied. We have studied in semiconductor, we have studied in the Boolean algebra too, and we are going to study in this one too because these are very important things. Okay, let me write its name in a different color. Okay, so and yes, you are familiar with and or obviously you are familiar with that. XOR, well, I told you, remember? NOT gate or inverted gate, remember? And well, maybe these two are a little new if you're not very much familiar with that already. NAND and NOR. Well, don't worry, we are going to focus and revise everything. If you have forgot that, no problem. We are going to study everything. Okay, so let's complete the definition first. And its output, or I can write outputs, only depends on the current input. So that's it. I'm not going to write anything else. This is all the thing. Well, so pretty much interesting. It seems like I have already figured out, oh, I am very intelligent. I know, my dear friend, that you are very intelligent. That's why I am attempting to teach you the great level of abstractions of the things in the digital electronics world because I only teach the people who are smart and who wish to be more smart by learning the thing and skills. Okay, with all that said, let's revise this and maybe understand that. Combination logic circuit. Well, logic is important here. So, logic circuit is a type of logic circuit. Well, this seems like I am writing the same word again and again, containing only logic gates. It means we are not using anything else. We are just using AND gate, OR gate, XOR gate, NOT gate, NAND gate, NOR gate. That's all the gate you are ever going to see in the digital electronics world. Well, so these are the only logic which is possible. And its output, the most important thing is output only depends on current state of the input. Like I gave you the example here. If it's off, it will off. If it's on, it will work. So it is not having its own memory. It works in the live state. That's what it means. So the main purpose of showing you this all the things is because that I want you to familiar with these things. This is very important. Why? Well, this is the fundamental thing by which we can do our logical calculations. Okay, so let's see something more on that in a new page maybe. Okay, So I want to present a note here to you for the combination logic. Okay, what is the note, Om? Well, the note is logic gates are not always required. What did you just say? Logic gates. Okay, let me write that first. Logic gates are not always required actually, because, well, I write the because in this way, you can try that too. Because simple logic function can be performed with switches, or you can say electrical switches. I'm just writing the switches and maybe diodes. Yes, actually diodes. So diodes. That's cheating, no? You said just here, just the backside. Please refer to the backside, then I will tell you. Okay, that's right. You said here that only, well, I'm highlighting it with a different color so that everyone can see. Only logic gates, containing only logic gates. And now flip the page, please. Not required? Are you joking with us? That's not fair, Om. Well, let me make it fair, my dear friend. Okay, let me ask you a question. Very simple question. You are switching on the fan, so do you think that any logic gate is required or any kind of the circuit is required in between? You just have to switch on the fan. The electricity will come through the wires, and the electricity that comes through the wires will going to reach to your fan, and your fan will start moving. So you just have to switch it on. That's it. There, it's connected. The circuit is complete and fan starts moving. So do you think that any kind of the logic gate is required and or not that kind of the logics? Well, it's not, because we just need two things, on and off. Just two commands, very simple commands. This is voltage, this is zero voltage. That's it. That's all what we want. So why do we require that all the things? Now you are making your point clear. But if you do something that requires dependency things, like let's say you have a calculator with no memory, you have a calculator which is not having memory. Believe me, these kind of the calculator do exist. Calculator not having memory. So what it actually do, you are writing, let me give you the example so that it becomes more clear. You wrote 2, it said okay. You wrote plus, it said okay. You wrote 3, it said okay. And now the answer is 5. So the thing is, these all things will going to get removed. After equal to sign, after when you mark this equal to sign, it means this all the value is going to update and give us the result 5, and this all will going to vanish up. This is our result. That's it. So this is the combination circuit. We require that there. And sometimes the better and efficient calculator use the memory, obviously. But the matter of the fact is, for the simple logic, we don't need that. We can use switch or diodes. That's it. So that is the whole logic. Okay, we understood the switch part, but tell us about the diode part. What happened with the diode part? You cannot just run. Tell us that what is in there. I don't got that. I want to learn this. Tell me. Tell me, tell me. Okay, let me tell you. What are actually diodes? Diodes are, well, Remember, we have studied the LED, light emitting diode. Ultimately, diode is something. Um, there is a crystal, and the electrons or current hit this crystal, and this produces the photons. And this is the whole story of LED, light emitting diode. Okay, I tell you a very short story about the light emitting diode, maybe the shortest one. Okay, there are so many kind of the diodes that can influence so many things. Like the Zener diode can work in breakdown voltages, like LEDs. Like there are so many diodes. Trust me. Well, I will tell you that later. I will add the notes about it where you can see the names. There's the names of all the kind of diodes which is possible and very much kind of popular things. Why I'm not adding them there? Well, it's not required. You can just simply imagine that for a specific purpose we have a specific diodes. Well, that's simple. What a diode actually do? It connects a circuit. Now this is the key idea. So this is the symbol of the diode. I hope you have remembered that. So cathode, anode, and all that plus things. I'm not writing this all. So this is the symbol of the diode, the simple diode. So what a diode do? Diode allow electricity to pass in only one direction and not in the other direction. It works in the other direction only the inner diode, and that is a kind of the exception. And that also even work in the case of, well, what? Do you remember that? Yes, that works on the breakdown region. Otherwise, diodes allow current to pass in only one direction. Only one direction. So it's only one direction function and it not work on both the direction. So that is the diode. Okay, with all that said, let's come back to our point. So why you said that we are ever going to use and or XOR not NAND and NOR. Well, with all the respect of all the technicians in the world, taking that in mind, my dear friend, you are going to become a digital electronics engineer, maybe a scientist. So we need to have entire details of that. Well, we are not the simple electrician who have to do simple circuiting. You have to think logically, you have to make them act as per the requirement. So you are studying a complex system. That's why we are going to study the and or not, XOR and NAND nor and all that things. So there is some meaning and you are learning something meaningful. That's why we are learning all these things. Okay, we will continue from the gates part in our combination logic in the next one. Till that point, take care, God bless, and enjoy learning.